Okay, so this is my video for Lab 4. I'm doing option number 2 because I couldn't quite get my green grass core to communicate back the information from the Lambda function with my other devices. Everything other than that I was able to successfully get set up. So I'll quickly just go through some of the components of the lab. I'll start with just walking through how I actually created these devices. So I know that was a component of the lab, was either writing some sort of script or automating the way that we create things in AWS IoT. I chose to do the option of using the AWS command line interface. So let me just quickly show and discuss those commands. So as you can see, I ran these sets of commands to create each thing that I created. So first was this AWS IoT create thing command, then was the AWS IoT create keys and certificate, and then I had to, I believe, actually outline, the specific certificate that I was using and the specific key. Then was attaching a policy to that, and so in doing that, you see I attached my IoT policy to that, and then attach thing principal was the next command, and then finally adding that iOS or AWS IoT add thing to thing group. So in doing that, those commands were typed in on my terminal to create a thing. So I did that for each device that I created. So that was step 1. Step 2 was then getting the things to communicate and send data to a specific topic. So I took this code from the lab and modified it slightly so that I could run. So let me just quickly show that actually functioning. So I'll click run code. Then it asks me if I want to send now. So I'll click S, and you see that data is sent there. So let me actually go to the AWS IoT and then the MQTT test client. And then let me check what the actual topic is. Let's see. So it's vehicle emission data, vehicle/emission/data. So then I will paste that in and subscribe to that. And now I will again send that data. So you see the data gets sent there. And we'll just wait a second. And as you can see, the data from that CSV file is getting sent and received to that topic. So there's proof of that working. The next step is, so this is where I chose to choose option 2 and where my stuff sort of stopped working. I outlined that in the report, but just to briefly mention, I completed this, basically the entirety of this AWS IoT Greengrass version 1 setup, and then I was halted, I think, around one of these specific points. Either way, I discussed it in the lab, and my issue, I think, was it was something involving Java not being on the device, so I'm assuming that maybe I just didn't correctly configure something in the artifact to allow or install correct version of Java, even though I did check and Java was installed on my core device, which is my Raspberry Pi. So I can quickly show that I did indeed create the Greengrass core device. So I actually created several and trying to troubleshoot this, but let's see. You can see that there. I think actually the one that I got closest to working was this Greengrass Core V1 core underscore Pluto, I called it. And then I'll just quickly show, this is my Raspberry Pi here. I'll just run so there you can see Greengrass daemon running. So as I said, I outlined in the report sort of the issues that I went through. I was able to get it essentially working to where I could run the component and log the information that was actually in this process.py, which I put in my GitLab. Yeah, essentially I could log the data, but when it came to sending that data back to the client or subscribing to a topic, I faced issues in using the SDK or the imports or whatever. It was really an import issue is what it seemed. But that's that. And then the final component of the lab was setting up the data visualization aspect. So let me just quickly go. I was able to follow that tutorial and using AWS Firehose and SageMaker and Athena and everything, create that database and then create a notebook instance. So let me just quickly open that. So I'll open Jupyter and I'll go to my visualizations notebook. And this was done by just placing that file as in the tutorial in an S3 bucket, and then using that, I think it was the scraper or the crawler or something to create the database. But I'll just quickly show that this is functioning. So I'll grab the data, and you can see the data types in the data frame. And I'll print that again. So out of my 3 visualizations, let me go ahead and start to discuss them. So this first one is just a heat map of the numerical attributes in the data frame. So I think this is valuable, as I said in this description, because at a glance it shows a correlation between numerical attributes. So that's given by the intensity or the color of the actual box. So you can just see at like a glance some of the specific things I outlined here that maybe for example, you can see a relationship between the vehicle angle and the vehicle speed have a decently strong negative correlation. There's some that are stronger, such as the correlation between vehicle speed and noise. So you can just see that based on if you find speed and noise, you can see that it's a pretty strong correlation. So that was my first visual, just at a glance, showing the connection between some of those attributes. So my second visual is a line plot between vehicle CO2 emissions and vehicle speed with a regression line in there. So I feel that this visual is valuable because it lets us see the connection between vehicle speed and vehicle emissions. We see in the above visual that there's a slightly positive correlation between those two. But to me, this visual is valuable because it points out that there's a ton of values that are appear to just be 0 for the vehicle CO2 emissions. So whether or not those are errors or not correct or indicative of some other issue, it makes me wonder if we remove those, maybe the correlation should actually be more indicative of what it may actually be, which would be potentially stronger, as you can just see sort of naively from the points on the graph. So that's my second visual. And then finally, my third visual zooms in on the relationship between vehicle speed and noise, as I had previously pointed out. So it's a line chart, and you can see on the x-axis the speed, and on the y-axis the average noise. So you can see in general it's mostly correlative. To me, this visual is valuable because it shows that it's not always the faster the vehicle is, then the louder it is. There's some cases where a vehicle is going to be faster in one case, but actually more quiet, or in another case it could be louder but slower than another vehicle. So I think that's valuable and something that you don't get from the just general correlation visual that I had above. So there's visual 1, visual 2, and visual 3.